The sun, the moon, the planets, the stars. These natural phenomena have nurtured, guided, and inspired life on Earth throughout the ages. Yet, it wasn't until the beginning of the 20th century, when aerial technology gave birth to the airplane, that humans acquired the technical capability to literally reach for the stars. Today, airplanes take us to altitudes of 30,000 feet, allowing us to fly above the clouds at nearly 600 miles per hour. Halfway through the 20th century, we invented the technology to go even farther, and the satellite era had begun. The first artificial satellites were launched to low Earth orbit, an area that extends to about 1,200 miles above Earth. The satellite era was destined to show the world that the sky could provide much more than intercontinental transportation, and NASA was created. Today, in the 21st century, over 1,000 operating satellites orbit planet Earth. They serve us daily with weather prediction, television programming, navigation, reconnaissance photography, radar imaging, and space-based internet. But today's most important satellite came at the very end of the 20th century. In 1998, assembly began in space on a satellite that would be second in size and radiance only to the moon. Completed in the 21st century, it was destined to enable us to support and improve life on and beyond Earth. Ultimately, this satellite was to become the springboard for nations around the world to prepare to take the next giant leap past our moon and into the solar system. This satellite is NASA's International Space Station. In an orbit about 250 miles above Earth, the station travels at a speed of 17,500 miles per hour, circling the globe every 90 minutes. The International Space Station was built with the cooperation of 15 countries. Under the leadership of the United States, 40 NASA space shuttle flights carried components to space for its construction between 1998 and 2011. Construction began with the Russian launch of Zarya, the foundation of what would become humanity's home in space. This first segment was built to provide basic essentials: electrical power, storage, propulsion, life support, a science lab, navigation tools, and multiple docking ports for the station components that would soon arrive. For more than a decade, additional modules, solar arrays, support structures, and other vital pieces were flown to space, and the station was assembled in orbit, piece by piece. Modules like the U.S. Destiny Laboratory provided one-of-a-kind research facilities, while others, including the Tranquility Module, provided vital life support systems and additional living space, eventually giving the station an interior volume similar to a Boeing 747 jet. America's international partners contributed additional segments to expand research capabilities to international science and engineering professionals worldwide. The European Space Agency contributed the Columbus Laboratory, which is connected to a mission control center in Germany. This addition has enabled station crew and Earth researchers to conduct thousands of experiments in weightlessness for life sciences, material science, fluid physics, and other disciplines. It also provides another port for external investigations. These have ranged from exploring how bacteria can survive on a meteorite in space to measuring volcanic activity 400 kilometers below on Earth. Next came the Japanese lab, Kibo, with research facilities focusing on experiments in space medicine, biology, Earth observations, material production, biotechnology, and communications. Kibo has a mission control room at the Tsukuba Space Center in Japan. In 2005, Congress designated the American segment as a national laboratory, directing NASA to invite other federal agencies and the private sector to use the facility. Completed in 2011, the station is the size of an American football field and can be seen among the moon, planets, and stars as it zooms over your house. To date, the station has hosted crew members from 17 countries, doing research in over 50 disciplines. Remarkably, 83 countries worldwide have used the research facilities. The completion of the International Space Station was one of the crowning achievements for NASA's Space Shuttle program. The workhorse spacecraft bore the majority of what is now the International Space Station into low Earth orbit, completing a task that no other vehicle could achieve. The retirement of NASA's 3 active shuttles produced a void in America's space transportation capability. Russia held the only astronaut transportation to the International Space Station. So, NASA made the bold decision to open the door to commercial companies, investing to develop low Earth orbit capabilities in space by pioneering private companies and fostering a burgeoning commercial space market. The station already had several international government spacecraft delivering cargo: the Russian Progress, the European Automated Transfer Vehicle, and the Japanese H-2 transfer vehicle. But America became the first country on the globe to permit commercial entrepreneurial companies to develop the capability to deliver cargo and, ultimately, astronauts to the International Space Station. Currently, 2 American companies, SpaceX and Orbital ATK, have transported cargo to the space station with their Dragon and Cygnus spacecrafts. And in the years to come, 2 American companies will soon begin launching station crews from American soil once more. The International Space Station's role in the development of your future, as well as that of the United States space program, is enormous. The station is humanity's best proving ground to provide the biological, scientific, and engineering knowledge needed to send astronauts safely on a round-trip journey to Mars. To continue preparing for this future leap into deep space, the station is being used as a test facility for the skills and technology that will be needed. NASA is also planning an excursion to capture a boulder from an asteroid and transport it to Earth's lunar orbit in the 2020s. The asteroid mission will use vehicles that are key components of NASA's deep space exploration strategy: the Orion spacecraft and the Space Launch System heavy lift rocket. But research done aboard the station isn't only benefiting the explorers of tomorrow. Many things learned in space are already benefiting life right here on Earth. The human body's reaction to microgravity is similar in many ways to its reaction to aging on Earth. Studies in nutrition and exercise on how to preserve a functional body in space can be applied to counteract the effects of aging on the human body on Earth as well. And with the first year-long mission on the station already underway, NASA is pushing the boundaries of the human body's capabilities further than we have ever gone before. Research on the fundamental mechanisms of plant growth made possible by the microgravity environment could lead to improvements in plant production on Earth and will be vital if future explorers want to grow food on Mars. Water purification systems developed and perfected on the International Space Station have been used in remote locations on Earth that lack reliable access to clean drinking water. Technologies developed for a human Mars expedition, such as faster long-distance communication, 3D printers for equipment parts replacement, and expandable habitats for spacecraft, can be utilized in applications to improve life on Earth. Circling the Earth every 90 minutes, the station enjoys a unique vantage point and orbits over most of the populated sections of Earth. Station crews have captured tens of thousands of images of the surface beneath them, documenting dramatic natural events like volcanic eruptions, earthquakes, storms, coastal erosion, flooding, drought, and tsunamis. Station cameras have also performed invaluable services to Earth, ranging from agricultural and ecosystem diagnostics to tracking ships crossing the seas. Commercial research and technology development are major growth areas made possible by the station's role as a U.S. national laboratory. The number of commercial research and technology projects increased from 3 in 2012 to 107 in 2014. Companies of all sizes, including industrial leaders, are using the microgravity of space to test and develop products. With an eye on the future, the station provides thousands of students with the opportunity to design and launch their very own experiments into space, developing the next generation of American scientists and engineers. Today, NASA and the International Space Station invite you to join us for the first opportunity in history to participate in the academic challenges and commercial opportunities available as NASA travels beyond Earth to understand and explore the solar system. Join us as a participant or as an interested world citizen as NASA takes many more small steps for man, but giant leaps for mankind.